Hi, I'm Mr. Smith and this is Learn to Code. So today we're going to work on how we can plan our programs. Oh, and just a side note, in case something sounds a little bit strange today, it's about 24 degrees where I'm recording this, so I've opened a window and would you believe it, a fly has flown into the room. It's making a buzzing noise, so if I get a bit distracted it's because I'm practicing Kung Fu on the fly. Anyway, so up until now then, all the programs you've written have been pretty simple. So the idea of planning them first on any paper would seem like, I guess, a less than valuable use of your time, you know, when you could be doing something else like watching Netflix. But hold that thought for a second, because spending a bit of time planning even the smallest of programs usually results in saving time and, more importantly, saves you becoming frustrated because something won't work as you want it to. Okay, anger moment over. Alright, so imagine then building a car without a plan. How would it end up? It might have 6 wheels, 12 seats, a steering wheel on the wrong side, and with the pedals in the wrong place. So where the accelerator is, it's actually the brake, and the brake's accelerator. Going to cause all sorts of problems, isn't it? So programming works in the same way. Okay, if we're building a car, we need a plan. We put things in the right place, in the right order. When the car rolls off the line at the end, it should work. Okay, and programming is the same thing. In fact, it's so important. There's an entire field of software engineering that is actually dedicated to doing just this. Let's look at a couple of simple planning tools and techniques that will make your life easier, at least as far as programming goes. We're going to start with algorithms and pseudocode. Okay, so an algorithm is a set of clear, easy to follow instructions for completing a task. The world's best algorithms are from Lego. Okay, step 1 shows you what to do. Step 2 adds a bit. Step 3 adds a bit more until you end up with a finished result. So we use pseudocode to be able to write our algorithms. Okay, and pseudocode is a language that is somewhere between English and a programming language. Here's an example. If there is bread in the cupboard, then get the bread out. Else, make bread. End if. Make a sandwich. Clear up. Eat the sandwich. Okay, pretty straightforward set of instructions. Pretty clear, easy to follow. Okay, now let's have a look at this idea of stepwise refinement. This is basically looking at your algorithm, your pseudocode, and breaking it down into smaller steps until it looks almost like a program. So in our previous algorithm, we had if there's bread in the cupboard, get the bread out, else make bread. Well, make bread, that's a little bit vague. Okay, so we need to make that clearer. So we're going to refine this. We're going to use stepwise refinement to refine that line, make bread. Okay, so if we look at the process of making bread, there are quite a few steps. And this is how we have used stepwise refinement, or how we have applied stepwise refinement to make bread. We take out the scales, place the bread bin, which is the metal container, on the scales, add 500 grams of strong white flour, add 25 grams of butter, add 1.5 teaspoons of sugar, 1.25 teaspoons of salt, 350 ml of water, place the bread bin in the bread maker. Add 1 teaspoon of yeast and turn on the bread maker. This is much more clear than just make bread. And actually, we could probably take this even further. Okay, because the process of turning on the bread maker, there are several steps included there. So we would just keep going on and on and on until we get this right. So that's the end of this lesson. The next thing you need to do is complete the challenge for this unit. and you're going to make a game called Guess My Number.